video, I'm going to go through the practice problems that are posted to Classroom. Okay, so we're going to follow the same exact steps with each of these. So I'm hoping that after going through 5 examples, we get the hang of this pattern. Okay, so I'm going to start with this first question. How many moles of carbon are in 132 grams? So the first thing we want to do is we always want to just write out what we are given. So here we are given 132.43 grams of carbon. It's very, very, very important that you are putting your units, okay? Okay, so because gram of carbon is in the numerator of the first fraction, we know that gram of carbon is going to go in the bottom of the next fraction. And to figure out what number we use, we are going to look at our periodic table, okay? So if we look at our periodic table, we are always going to look at the number that is right here. So here for carbon, 1 mole of carbon weighs 12.01. Okay, and for the rest of these, we are also going to be accessing the numbers that are on the periodic table that are representing the mass of the atom. Okay. All right, so, So we have 12.01, and that is how many grams are in 1 mole of carbon. And remember, the abbreviation for mole is MOL. Okay. So then to solve for this, we multiply 132.43 times 1, because we want to multiply across, okay, equals, and then we divide by the 12.01. And the answer that we get, this is what my calculator looks like, 11.026. So we always want to round to the 100th, so I'm going to put 11.03. If I'm looking at this, I could cross out grams of carbon, and that leaves me with moles of carbon, and that's my answer. Okay, so let's look at this next one. How many moles of water are in 115.52 grams of water? So again, we always write what we're given in the first spot. So 115.52 grams of water. Okay. And then we know that grams of water is going to go in this spot as well. But we need to figure out how many grams of water are in 1 mole of water. So to do that, we're again going to look at our periodic table, and I've just copied those numbers here just so that we kind of have them. And I'm going to be looking at the formula for H2O. Okay, so in water, I have 2 hydrogens and I have 1 oxygen. Okay, so in water, I have 2 moles of hydrogen. 1 mole of hydrogen weighs 1.008. And then I also have 1 mole of oxygen. 1 mole of oxygen weighs 16.00 grams of grams of hydrogen. Okay, so we get 16.00 grams of oxygen within 1 mole of water, and we have 2.016 grams of hydrogen. Okay, then we just are going to add these numbers together to get 18.016 grams per mole of water. Okay, so I'm going to go back to my work now. So I have a number that I can plug in here, 18 0.016 grams of water for every 1 mole of water. Okay. And then again, as I'm solving for this, I'm going to be doing 415.52 times 1 divided by 18.016. Okay. And this is what my calculator looks like down here. Okay. So 23.063. So my answer is just going to be 23.06 because I always round to the 100th. Again, I can cross out grams of water. Oops. Eek. Okay, so I can cross out grams of water, and I end up with moles of water. Okay, so for my next one, for this I am asked how many moles of hydrochloric acid are in a 62.4 gram sample of hydrochloric acid. Okay, so again, I type out what I'm given, 62.4 grams of HCl. Since gram of HCl is in the numerator of the first fraction, gram of HCl is going to go in the denominator of that next fraction. For hydrochloric acid, if I'm looking, I have, so within hydrochloric acid, I have 1 mole of hydrogen, and I have 1 mole of chlorine as well. So 1 mole of hydrogen is equal to 1.008 grams of hydrogen. And I just solve that out again. 1 mole of chlorine. So 1 mole of chlorine is equal to 35.45 grams of chlorine. I solve that out again, and I get 35.45 grams of chlorine. Okay. I'm then just going to add these numbers together to get 36.458 grams per mole of hydrochloric acid. Okay. So I'm going to come back here, and that's the number I put here. So 36.458 grams of hydrochloric acid is equal to 1 mole of hydrochloric acid. Okay. And then again, I'm just going to solve this out. So 62.4 times 1 divided by 36.458. Okay. And again, just going to show what my calculator says down here at the bottom. Okay, so I have 1.711. So my answer is 1.71 moles of hydrochloric acid. Okay, and something you'll notice, I'm rounding to the 100th here. I am not rounding to the 100th here. Okay, so I only round to the 100th at the very end. Okay, so here's my next question. So how many grams of calcium nitride are in a 5.6 mole sample of calcium nitride? So again, I'd start by typing what I know. So I know 5.6 moles of calcium nitride. Okay. Since mole of calcium nitride is here, mole of calcium nitride is going to go down here at the bottom. Okay. And now I just need to figure out my molar mass of calcium nitride. So if I look at my periodic table, I see that I have Ca3N2. Okay, so I just got these numbers from my periodic table again. Okay, so within calcium nitride, I have 3 moles of calcium. So over 1, I'm going to multiply that by, so 1 mole of calcium weighs 40.08 grams. And then I also have within 1 mole of calcium nitride, I have 2 moles of nitrogen. 1 mole of nitrogen weighs 14.01 grams. Okay, so I'm just going to multiply this stuff out. So 3 times 40.08 is 120.24 grams of calcium. 2 times 14.01 is 28.02 grams of nitrogen. Okay. And again, I want to add these two together. So 120.24 plus 28.02, I'm going to get 148.26 grams per mole of calcium nitride. Okay, so I'm just going to take this number back here. So I know that 1 mole of calcium nitride is equal to 148.26 grams of calcium nitride. Okay. So then I just multiply across and then divide down. So 5.6 times 148.26 equals, divided by 1, and I end up getting 830. So 830.256, which I'm going to round to 0.226. Okay. Moles of calcium nitride and moles of calcium nitride are going to cancel out. So then I end up with grams of calcium nitride as my unit. Oops, and I may have just goofed there. Oop. All right. Okay, so this last problem, how many grams of magnesium phosphate are in a 0.05 gram sample? Just noticing a typo there that I will fix before you all see this. Okay, so what I'm going to put here is 0.05 grams of magnesium phosphate. Okay. Oops. Actually, this should say moles. Sorry. That's why units are important. Okay, so since moles of magnesium phosphate is at the top here, moles of magnesium phosphate goes at the bottom here. Okay, and now we just need to figure out how many grams are in 1 mole of magnesium phosphate. So magnesium phosphate is Mg3 PO4 2. Okay, so let's count this out. So within 1 mole of magnesium phosphate, I have 3 moles of magnesium. Okay, so 1 mole of magnesium weighs 24.31 grams. Next up, I have phosphorus. So that's this P. So I have 2 phosphoruses. And 1 mole of phosphorus weighs 30.97 grams. And then finally, I have oxygen. I know that this is phosphorus and oxygen and not polonium because both the P and the O are capitalized. If the O is not capitalized, that would be polonium though. Okay, so 4 times 2 is 8. So I have 8 moles of oxygen in 1 mole of magnesium phosphate. So 1 mole of oxygen weighs 16 grams. And then I just want to solve this all out. So 3 times 24.31, I get 72.93 grams of magnesium. 2 times 30.97, I get 61.94 grams of phosphorus. 8 times 16, I get 128 grams of oxygen. And then I want to add these all together. So 72.93 plus 61.94 plus 128, and I end up getting 262.87 grams per mole of magnesium phosphate. Okay, let's go back to our work. So 1 mole is equal to 262.87 grams of magnesium phosphate. Okay, and then to solve this, I just multiply across and then divide down. So 0.05 times 262.87 equals, and then divide that by 1, and I end up getting 13.1435. So I'm going to round that to 13.14. If I look at my units, moles of magnesium phosphate, if I can remember how to do this, whoops. Like forgetting how to do some of these keyboard shortcuts as I'm doing the video. Okay, so moles of magnesium phosphate here cancels out with moles of magnesium phosphate here. So my unit that I'm going to end up using is grams of magnesium phosphate. And that's my answer.